Hi everybody, welcome to Physics 2 course, which is electromagnetism course, which is a course for the first and second university years students. I use this course a standard book, a standard general physics book. You can use your own book, which the physics is the same in any of these books. Now, at the beginning of each course, we should discuss and define some physics quantities. In this course, we need to define something or some quantities that related to electric and magnetism. The first one, what we are dealing with is the electric charge and the electric field. We are not going to discussing the electric field, but we will start with the electric charge. What is the electric charge? What is the charge? Actually, it's a thing. Anything in this universe is a thing. This thing is considered to be a physics quantity. This quantity is just like the mass, like the weight. It's an intrinsic property of the material, just like the mass. Every material has a mass. This mass is big or small. This quantity is a quantity related to that material, and this quantity related to its electrical situation of that material. Maybe some materials are neutral, there's no charges on them. Maybe some of them are positively or negatively charged. From the high school classes or from previous experience or from our knowledge, we know that if we, for example, rub some plastic piece or rod with a piece of ore, then one of them will be negatively charged and the other will be positively charged. And using this rod with some small pieces of paper, it will attract them and it will show us that this rod is charged. Now, basically, what is the charge, from where the charge come, and what is the properties of that charge? After understanding these questions and their answers, then we will done with this lesson today, and we will start to understand what we need to apply using this quantity in physics. Actually, the previous physicists in classical physics, they decided and they found actually that the charge came from objects, from the matter. For example, if we have the plastic piece and the 4-piece, and we do this experiment, then one of them will be charged by negative, the other by positive. We don't know enough about positive and negative yet, but the charge came from them. It didn't came from outside this system, this closed system, which is the piece of plastic, piece of 4, okay? So that charge came from the material. Let us remember the construction of any material. We know that the material is composed of atoms or molecules. Let us talk about atoms. This is the simple model for the atom. It's a nucleus with electrons rotating around that nucleus, and there's some neutral neutrons inside the nucleus and some positive protons inside that nucleus too. And there are many electrons rotating around this nucleus in orbitals, and the number of these negative electrons is the same as the number of the positive protons inside that nucleus. The nucleus is fixed in its place. We cannot move a nucleus from its place. Just we can do that by dividing the material. We just divide the material, then that we are moving nuclei from one place to another and separate them. But the electrons, they are already moving, so we can study them easily. We will see that now. So the electrons initially defined and discovered by Thomson in 1897, and the proton was found before 1970, 17 or to 20. It was found in the 80s, late 80s, but who defined that this particle is a proton is Rutherford. But totally, the material in general should be neutral, and there is no charge for any material. For example, this atom is atom, it is not an ion, so it is neutral and it has no charge. Okay, next. How the things become charged. We have the simple experiment by using a rod of plastic with a piece of foil. If we're rubbing them, it is not just rubbing, it's actually there's energy between spent here, and there is a work done. So this energy is gained between these two pieces of matter. The energy means movement, and this movement is available just for the electrons between these two materials. Some materials tend to lose electrons according to their molecular structure. Some material tend to gain or to attract these electrons, so this material will be negatively charged, and the other materials which like to lose electrons will become positively charged. Actually, during this interaction, energy will be transferred from body to another, and the most likely particles like to gain this energy is the electrons, and these electrons will be easily freed from the surface of one material to go to another material. In this case, and we will see how this will happen, in this case one material will be positively charged and the other is negatively charged, but the nuclei again will stay in their places. Some other examples how material will be charged. For example, if we have a plastic surface and the sun attack it, the sun rays or photons will transfer some energy to the electrons and allow these electrons to escape from this surface and leave this surface positively charged, and the electrons go with the wind. Okay, some other example, which is we see it always if we have in dry days and we have dry wind. This wind is rubbing or attracted with interacted. This wind interacted and rubbing with the bodies like the house or the furniture inside the house and make this body or that charged. When we interact with this body, we can see some sparks or some annoying feeling by discharging. You know that. I believe that. Or we can do this professionally by doing an experiment, which is a simple experiment, by closing a rod with which is charged rod to a piece of metal, for example, which is the second object here. If this rod is charged by negative charge, then it will repel the negative charge, make them go away from this closed side, make the positive charge in the close side and the negative charge in the far side. Simply, if we remove this first object, then the negative charge will go back, and the second object will still also neutral without charging. Now, if we need to make it permanently charged. Now, if we need to make it permanently charged, we need to let those negative charge, for example, free to be escaped from that side by grounding. By grounding, now these negative charge will escape to the ground. Again, if we make this negative charge go away, then the negative charge will return back from the ground. But what we need to do is cut the grounding at first, then removing the effective negatively charged rod. In this case, we have more positive charge on the second object with less negative charge on it. Leave it positively charged means that we have positive charge more than the negative ones. Now we need to focus on the properties of the charge. The charge, we have an important law in physics or in nature in general, which is the conservation of things. Conservation of momentum, energy, mass, and so on. We have also the conservation of the charge. If we have any closed system and we have an object, and this object with zero charge, which is neutral, if we need to charge it by positive 5 units of charge, then there should be another object with the negative charge with the same magnitude. So the total charge before in that system should be equal to the total charge after. So we cannot create new charge or decay a charge. So this is a closed system, and the charge should be should be conserved in that closed system. Also, another thing, we have the like charges with their signs are repelling each other, but the opposite charges are attracting each other. This is electric force. Electric force, it's an important principle to understand that we have more than one force in nature. We have magnetic force, we have nuclear force, we have gravitational force, and we have electric force. We need to study this force, its properties, and how we can apply this force. We will do that in this course. Now, what is the charge unit? What is the smallest charge available? Also, what we mean by the quantization of the charge, or why the charge is quantized. Now, the charge is a quantity in physics, and every quantity in physics should be defined by a magnitude, which is a number, and a unit, and the unit is coulomb, after the scientist Coulomb. Also, it's important to notice that 1 coulomb is a big quantity. For example, 1 Newton is a force which is a sensible force for us. For example, the water filling this cup, which is 100 milligram weight, the force of its weight is 1 Newton. So we can sense this force 1 Newton in our hand, which is an easy thing. But 1 coulomb is a big quantity. So in this course, we are dealing with small quantities of that big quantity. So we will deal with milli coulomb, which is 10 to negative 3 coulomb, or macro. This sample means macro coulomb, which is 10 to negative 6, or 1 millionth, or nano, which is 10 to negative 9, which is billionth of a coulomb. And the common sample used in the solution for any problem is Q, which is in the higher case or lower case. So the sample of the charge quantity is Q. And the smallest charge, stable charge, or the break to build the other charge is the electron charge or the proton charge, which are the same with negative sign, which is equal to 1.6 multiplied by 10 to the negative 19 coulomb, which is small quantity. The sample what used for electron charge is E negative or QE, and the same for the proton, QP or P plus. There is no smaller charge than this one. The electron is a particle, which is an elementary particle. We cannot divide it to smaller pieces, but the proton we can divide it to smaller pieces. Actually, it is very stable. It is composed of other pieces, and these pieces, some of them are with charge third of this charge or 2/3, but these quantities, which are the quarks, they are not stable alone. They should compose another particle, and the smallest charge according to that is the same charge, which is 1.6 plus or minus times 10 to the negative 19 coulomb. We mean by this, the charge is quantized. We have just integer number of charge. We don't have half or third of this charge quantity, which is the charge of electron. We can apply some example here with some quantities. I'm asking, you can see this question, which one of them is real charge, or in different words, how many electrons or protons in this charge. We have Q1, which is the first charge, and I assume that this charge is negative 1.4 E negative 19, which is 10 to the negative 19. Okay, the scale is 10 to the negative 19, which is the same, but the charge here as the electron I'm talking, 1.4 is smaller than the electron magnetic charge, and if we divide 1.4 over 1.6 is almost 0.875, which of electron. We don't have any charge like this. Let us, for example, solve it for the second one, which is negative 1.6, which is the same number, but no, we have another thing which is important, which is the scale. Here we have 10 to the negative 20, 10 to the negative 19. This, to convert this to this, it's negative 1.6 times 0.1, 1/10, times 10 to the 19 negative. So this make it 0.16, which is 1/10 of the electron charge with the same scale. So we cannot find this charge. This is not a real charge. What about the third one? It's 3.2 with negative sign times 10 to the negative 18. 10 to the negative 18 is bigger than 10 to the negative 19 by 10 times. And we have negative 3.2. Again, the sign is for electron or proton, negative or positive. Now, to put this as negative 10 to the negative 19, we would multiply it by 10. So this charge equal to 3.2 with a negative sign times 10 times 10 to the negative 19. This is equal to 32 times 10 to the negative 19. And if we divide it by the charge of the electron, 1.6, 10 negative 19 again, it will give us 20. So we have 20, which is an integer number, or we have 20 electrons composing this charge. So it's a real charge. What about this one? 100 times 10 to the negative 16, which is much bigger than negative 19 in this scale. 10 to the negative 16 is 1,000 times bigger than this. Time it by, multiply it by 100, make it 10 to the negative 14. If you divide it on the charge magnitude for the electron, it will give you an integer number, which is this one. So this is a real charge. Actually, for large or huge charge, what we deal in this course, like micro or nano, we don't care about the quantization of the charge because it is much bigger than what we considering that the electron charge is. Now finally, we need to discuss simple things about the insulators and conductors. As we defined before, the atom components, we have the nuclei, we have electrons rotating around them in the orbitals. There are some electrons which are in the inner orbits. They are tightly or strongly attracted to their mother nucleus. They cannot escape, actually, enter under any small forces. But for the outer electrons, if we give them some energy, they tend to escape. Especially if you know that there is another positive nucleus on the other side attracting them. This makes the escaping easier for them. Once they are outside, they are not belonging to any one of these atoms. They will be free electrons. Maybe sometimes some atom capture them and keep them here temporarily, but they will escape again at the daily temperature, at high temperatures. But in general, we will have in this material some free electrons, defined as free electrons. So the material composed of nuclei and some free electrons inside and on the surface of any material. Okay, to study this in physics quantitatively, we need to define thing, and we need to study, for example, some insulators or conductors or semiconductors. So we need to consider a volume for this. Consider 1 cubic meter of that material, for example the copper. In this 1 cubic meter we can count number of atoms according to the mass, to the atomic mass of copper. We can count how many atoms here, but we will not do that. Also we can count the total number of protons or electrons or neutrons here, but we will not do that too. Also we can count how many we have free electrons, but we will not do that. But I will mention just a number. For copper, for example, we have number of free electrons inside 1 cubic meter equals to 8.4 times 10 to the positive 28. Means we have 28 zeros follows this number, which is very huge number of free electrons inside 1 cubic meter. For silicon, which is a semiconductor like carbon, we have number times 10 to the positive 16. It's a big number, but it is not huge number. So this material is semiconductor material. What do you think about insulators? If you look and Google that, you will find that they don't have any free electrons. That is not right or not exactly true. They have some free electrons like thousands or millions, but they are much smaller than the semiconductors, for example. I'm talking here about dried wood. It doesn't have any humidity or water inside it, so there's no ions to carry the current or the charge from place to place. So for insulators, we don't have any free electrons. we can say this, but it is not accurate actually, because for example, you know that we have wires, we have plastic or rubber to insulate them, but some types of plastic is better than others, or rubber. So we have differentiation in the number of free electrons in insulators, but keep them all in the low voltages, non-conducting materials. And this, the conductivity or the free electrons depending on the temperature. We talk here about the real life temperature, which is about 20 to 30 centigrade or Celsius. In physics, we are dealing with temperature in Kelvin unit. So the zero temperature in Kelvin is negative 273 almost Celsius. For example, in the outer space, the temperature is negative, no, not negative. In the outer space is 2.7 almost Kelvin, which is almost negative 270 Celsius. At this temperature, everything is frozen, even the electrons. We don't have free electrons at 0 Kelvin. So most of the material, or all the material, will be the same. There is no conductivity and all of them are insulators. This is a little bit about the charge, the electric charge and their properties. We will study more in the next lessons. Thank you.